Hey everyone, just doing a quick video of piecewise functions and how you can use those in shading. So real quick, I'm going to open up a new Desmos window here, and we'll talk about the notation, and then we'll go back and do it for the project. So if I have, say, something like y1 is x squared, just do something easy, and then maybe something like y2 is maybe 2 minus x, something like that. You may want just a piece of one and a piece of the other, and sometimes it's useful to actually combine those together. So this is using piecewise functions. So what I'm going to do is say my new function, which I'll call y3, is going to be this parabola for everything to the left of 1. All right, so all the x's left of 1, I want to use a parabola. And to do that, I'll put in a curly brace and then say I want my x's less than or equal to 1. And I'm going to put in a colon and then put in the function, right? So x squared. So this is sort of your restriction, then the colon, and then the x squared that comes after that. All right, what you want to do then for the other piece is you want to put in a comma. All right, so we'll put in a comma and then do the same thing. So restriction, I want x's bigger than or equal to 1. And I also want to use the function, which is that line, 2 minus x. And so when I type that in, then I get those guys. So I can hide it and see where I'm using that parabola just for this left piece where x is less than or equal to 1, using this right piece for x is bigger than or equal to 1. Unlike normal piecewise functions where you can't have the same values defined right on more than one piece, this one I would be able to use it right the same for the equals, although I wouldn't need it, right? I could just say x bigger than 1, use it there. If this were something like a 3 minus x and I had it equal to 1, right, then it may not know exactly what to do at right 1. So at 1 it says 1, 1, right? Kind of jumps me down to this one, so it'll take whatever it knows is 1 that was defined first. So you can use the equals, but they won't actually do a lot of stuff if they overlap with some of these other guys. Even if I use, say, x bigger than or equal to 0, right, it's not going to use it because I've already defined some stuff for between 0 and 1. So that's some stuff you can type in that won't really do anything. So by and large, you can just stick with where do I want these defined, and then the function, where do I want it defined again, then the function, and just keep going from there. And you can do more than 2 pieces. You can do 2, 3, 4, as many as you want, 10 pieces, as long as you have the restriction, that colon, then the function, comma, and then do the same thing for all the rest. Back over here in the graphing project, we'll go ahead and do that for these two, the red and the green. All right, so this x1, x2, we'll go ahead and define that again as this new x function. We'll come up with a name in a minute. And then I'm going to do the same thing, curly brace, and then I'm just going to copy this restriction, right? So this is 2.4 to 4.1, so I'm going to copy that, put that in there, paste it, colon, and then the function, right? So again, I can copy and paste, and you can also just type x1, x2 if you want, but then if you ever delete the x1 and x2, it won't know what to do. So depends on what your uses are and if you plan on deleting things later. If you just want to copy and paste, or if you just want to use the names that you already had. So let's go and put in this next one. So here's a new function. All right, so copy, paste. And again, even though this says 3.95, I really could go from 4.1. So if you want to modify that a little bit, you could, because it's not gonna 4.1. It's not going to use anything below the 4.1 because it's already defined from this first one. All right, so I got that, and then colon, and then paste that rational function in there. Copy, paste, and that should be that entire blue line right there on the right. We'll change that to orange just so we can see it apart from the other blue line. So there's my new function, right? That's combined from both the red and the green, now just into one. So what that means for the shading is I could call this, maybe we'll just name it X4 for now. I'm going to rename those in a minute, but I could say X3, right, less than or equal to X, less than or equal to X4, right, and that'll be completely shaded in, and I can make that black and have, and now even if I wanted this lighter shade, right, there's not the overlap that you might have got doing it with the other way, and I can just go ahead and put in that as a 1, right, for the opacity, and then we'll go ahead and leave it there. So that would be that new, right, stripe that's going in right there. So that would be the stripe on the hubs for that piece, using a piecewise function as the definition on the right. I could then delete these two, right? So if I want to call this, let's say, RA for right arm, I'll leave that in the subscript. So RA for right arm, and then we could say stripe 1. And then we'll call this, instead of 3, we'll say right arm, RA, stripe 2. And maybe I want this one to be 2 and this one to be 1. And then I would need to rename those again, kind of right there. So I'm just going to copy and paste those in. So this was our stripe 1 on the left, stripe 2 on the right. And now those are redefined again for that part. So that's kind of it. If you want to use piecewise functions, or if you want to shade in the other video like we did with just the basic functions, doing multiple, right? The advantage here is I only need 1 inequality and not 2 inequalities. So it's kind of up to you how you want to do it. If you don't mind more inequalities, you can just do it that way. You wouldn't necessarily have to have the piecewise part. So anyway, hope that helps as you're thinking about planning stuff for the graphing project. And like I said, we'll have a more advanced video on shading that comes a little bit later. That's it for now. We'll see you on the next one.